All right, here we go. Advent code day 9. All right, disk map. I'm guessing my test input. Let's see what we got. Um, 10 gigabytes free space by compacting all the files. Program that you offer to help. This map. Wait, is that my? Oh no, this. Oh, it's a little bit bigger. That's my puzzle input. How many characters is that? 20,000. Okay, a lot. Um, The space uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 12345 would represent a 1 block file, 2 block free. Okay, right? Okay, and then 5 block file. Each file on the disk also has an ID number. Three files, right? One, two, three. Okay, that's fine. Using one character for each block, the disk map represents these individual blocks, right? The first example above, wait, what? Okay, represents these individual blocks. Right, okay, that makes sense. I get this. To move file blocks one at a time from the end of the disk to the leftmost free space so there are no gaps, process looks like this. Okay, so we're going to move two. Okay. Um, what? Okay. I'm trying to think of how to do this without an array of size, because it wouldn't be size 20,000. It'd be a really, well, I guess in a worst case, it would what, be an array of size 200,000. Maybe that's not that bad, but okay. Calculate the checksum. The leftmost block is in position 0. Block contains, skip it. Okay, so it's 0, 0, um, okay. All right. So first, there's only one line, so it's actually just going to be val of disk equals line0 dot trim, and then all right, so let's just pass this uh disk there. Okay, so now okay. So my thought here is um what would it be? First, let's just check. Okay, disk dot sum of That would be car digit to int. Let's just check. Let's check how big this sum is. Let's just check how big this sum is for my input and see if doing an array is now feasible. Okay, yeah, you can do an array of that big. That's not a problem. I think that's probably the easiest way to do it then. So yeah, I think I'll just do that. So there's going to be val disk array equals array int of size right. I think that's right. Yeah. And then I'm going to initialize all of the values to -1. So that way I know what's empty is -1. And then from there, I'm going to have var file ID equals 0. And then for I in disk dot toCarArray dot map it dot toInt. Actually do this here. Sorry, I'm sort of cleaning my code as I write it. But for file and disk, and this is going to be var is file equals true if is file, oh, and var current index equals 0. So if is file equals not is file, then we're going to set, so if it's 5, I'm setting from, it would be current index dot dot less than current index section length plus section length, and then it's going to be dot for each and we're just going to do disk array. I don't need to add the current index. It's just going to be it equals file ID and then file ID plus plus. Why does it not like this? Oh, that's fine. And then current index plus equals section. I think that's it. To get, so let's do disk array, And I'm going to do dot sub dot slice. And I'll just do 0 until 20. How big? Let's look at my test input case again. Because what I'm trying to get to is this. So actually, let's just do print disk array. So now we're going to do test input. And I'm just trying to get to that. Oh, right. Looks like, yep, I got exactly what I wanted here. Okay, and then from there it's just backfilling. And so, um, val, let's see. Front, first, empty index equals right dot index of -1, and then val last index equals disk array dot just last index. And then what I'm going to do is while last index is greater than or equal to first index, right? And it's going to be if disk array last index does not equal -1, disk array first empty index equals disk array last index disk array last index equals -1. And then I'm just going to step forward while disk array first index does not equal -1 plus. All right, these need to be bars. And then while disk array last index does equal -1, last index minus minus. Print line. Oh, I did it again. Dot to list. Did that fill in the way I want it to? Looks like it did. Okay, cool. So then the last step is just so, all right, breaking it down. This first part is just filling in the initial array. This part is doing the backfill. The nice thing is both of these are O of n. I'm avoiding any O of n squared here. And now it's just the checksum. And so this is just or or actually it'll just be disk array dot filter not it equals -1, which we can ignore in this case. We're going to do dot map indexed, and it's just going to be the file ID times the index. So (1928). All right, we got the test value. So now let's apply that here. Only I'm worried about getting a long. Oh, I don't want to print that, but let's actually turn this into dot too long, and it's just because I sort of worry about this being large enough to be a long. And it's a good thing I did that, because it is in fact a big enough number to be a long. All right. Upon completion, two things become clear. First, the disk definitely has a lot of contiguous free space, just like blah, blah, blah. Second, the computer is running much too slowly. Maybe in all that file fragmentation was a bad idea. Already has a new plan, rather than, yep, this is exactly what I thought. Okay. Moving whole files instead. This time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Okay. Okay, so 9 moves. And then we get down to the 2. Well, we don't get down to the 2. Okay, then we go to the 7. Right. Okay, so we only do one pass. We're only doing one pass. I see. We're only doing one pass. So then 6 can't move because there's no space for it. 5 can't move because there's no big enough contiguous space. The 4 can move. The 3 can't move because there's not a big enough contiguous space. All right. And the 2 can move. It moves over here. Okay, so now this process is still largely the same. So what I'm actually going to do is this is going to make my array. This part is just backfilling my array. Okay, so I'm going to copy this for part 2. But then specifically, it's going to be I think I know how I want to do this. What I want to do is I want to get a map of the length of a gap and the starting indices. So I'm going to do for int or for I in I'll do it this way. Var I equals 0. And while I in this, and the reason I'm doing a while loop, I know that looks awkward, but it's because of what I'm going to do next. It's a bit weird, and it's just going to be yeah, if that equals -1, then what I want to do is I want to say, okay, loop forward until I reach something that is not -1. I does not equal -1, or no, while it does equal -1, excuse me, then I'm going to do I plus plus. If it does equal -1, then while it equals -1, I'm going to do I plus plus. That'll give me up to the next index. So like if I start at index 2 and then 3, 4 is blank and then 5, yeah. So the length is actually let's do var j equals I. While j is that j plus plus, and then the length equals j minus I. And then from there, so this is going to be my var or val length map equals mutable map of int and list int. And this is my map of empty section length to index. And why am I doing it this way? Because I don't need to do it this way. I can do it this way. I can just do it like I'm getting the lengths the first time, right? Here. Herpa-derpy-doo. Because I can just do else, and it's going to be length map and it's going to be length map. Um, what's the value? Section length equals get or default. Oh wait, no. Okay, it's going to be length map dot get or default section length. So plus current index. Let me just make sure this is working right. Yeah, this one is I have the mental model, but then like I sort of find myself trying to think too far ahead. Right. Okay, that's exactly what I wanted. Um, I don't really want to bother with 0. I just worry about that messing up my logic. Okay. And so initially there's some 3 gaps, and there's a bunch of 1 gaps, right? Okay. I'm trying to avoid doing an n squared. It's this might be too big for an n squared, is what I'm trying to avoid doing. Okay, so I have this map. So then it's just going to be, and actually let's, all right, so now I have an index length map. So it's going to be, do I want to map length? Do I want to map index? I think. My brain's not working right now. I think I'm just too tired. I need sleep. Um, I'm gonna come back to this tomorrow. I'm gonna pause on part 2 for now. Because I keep losing my train of thought of how I want to do this. I have a mental model, and then I tired enough that my brain is kind of scattered. What I'm planning on doing, so I'm planning on taking a map. And what I'm gonna do, since I know that I'm only dealing with digits 0 through 9, I'm gonna reverse the map I had. So rather than mapping the no, that's so I'm gonna have a map for the gaps, or is it just a list for the gaps? The problem with doing a list for the gaps is that if I do a list for the gaps, I'm potentially building an n squared solution. And I think there's an easier way to do this than the way I'm thinking with sort of, it's going to need like 3 maps. So I think I'm just too tired to solve this problem right now because it's the middle of the night. So I think I'm going to come back to it stream tomorrow. So this is only part 1. Part 1's in the books. But I'm not going to get to part 2 right now. I need sleep. So, see everyone then. Take care.